Hello.
I know the song.
You know this one?
Like it's sorry about this.
Oh, you know
Could
it.
be that.
That might be it. That might be it.
No, I'm not a believer. Well, not like. No, I'm not. It's just another person.
What? The dancing?
Yeah. Are they Japanese? Yeah. I don't know. Must be one of the Japanese. Okay. Well, I didn't know this was going to be so.
I don't know. It's so random. What's that? You can speak Japanese? Oh, you can speak that. I see. Good. You're that much of a believer, huh?
Ah,
Oh, so close.
Might as well be two.
Have a seat. I'm happy to have you here.
We're gonna get like 5 seconds.
Good.
You're close. You're so close.
So close.
So.
Not so close. Close-ish.
You were 20 seconds later.
Good day.
And this.
Welcome back. Quick warm-up. Discuss with your partner. How do you find x and y intercepts of any function? Don't talk about it yet. And asymptotes. All types of asymptotes. Take a moment. This is the last day, then we have review and the quest.
Well, yeah, no, the question on Tuesday.
I think it's Thursday, isn't it? Let me check. Let me check.
Yeah.
Let me check. Not this week. In between. It's class after next.
It's. No.
Are we ready? I have some questions. So, how do you find x-intercepts Jack?
Set y to 0.
So for x-intercept, you set y equal to 0. Excuse me, please. And the y-intercept? Thank you. Are we good with this? Pretty straightforward. No, you're not okay with it?
Huh?
No? Okay, good. Okay, asymptotes. There's lots of different types of asymptotes. Ben, tell us one thing about asymptotes.
There's two different types.
One thing.
Oh,
There's two different types.
Okay, just tell us about one of them. Or is that it? Two different types? Is
wait,
that the one thing?
oh, that
Vertical and then there's a horizontal.
Okay, so tell us about vertical asymptotes. How do you find it?
Vertical asymptote is zero. So like when we did the multiplicity,
Uh-huh.
like wherever it intersects with the or with y equals 0,
Okay,
we're gonna draw. We draw in the vertical asymptotes, and what they do is like it's how they guide you for when you're drawing simple graphs.
okay, so if you start with a polynomial graph and you find an x-intercept, and you make the reciprocal of it, I think what you're saying is that zeros become the vertical asymptotes. Does that sound like what you remember from what we've been doing? Or what you've seen on the video, perhaps?
Yeah.
Okay. What else do you know about vertical asymptotes? Thank you. Anything else? I guess we'll see as the show goes on. It does have to do with zeros in the denominator if you're given a rational function, just set the denominator equal to 0. That's what vertical asymptotes. Okay, so there's vertical and you mentioned horizontal asymptotes. Upton, what do you remember about horizontal asymptotes?
I do vertical.
I think we
Wait,
did.
is-
Was there something else about vertical?
I was thinking about like top heavy and bottom heavy.
Oh, nice. Okay.
But
so
like,
if-
I don't really know.
Okay.
What's horizontal?
But remember that there's it has to do with bottom heavy, top heavy. Thank you.
Yeah.
Okay.
That is not.
Exactly. So when we're dealing with a fraction, or these are all rational functions. So who could build off of that? Do you want to continue?
Oh, sure.
Who'd like to build off of that? So bottom heavy, top heavy. Yes.
Top heavy by one, that's oblique asymptote.
Asymptote, yes. Top heavy by one, oblique or slant asymptote. Thank you.
But it's top heavy by more than one. That's what we saw like the curve.
Yeah, exactly.
how many by 1 degree?
By 1 degree. Thank you. Okay.
If they're equal,
What day do you want
then you pick them.
Oh, I guess you got it.
Okay.
If they're equal, then it has what kind of asymptote? Yeah, you divide the horizontal asymptote. That would be y equals top over bottom leading coefficients. And the last one, of course, is if it is not top heavy, not equal, but bottom heavy. Maybe this is the simplest one, bottom heavy. In this case, it has horizontal asymptote y equals 0. Okay, so we're going to be bringing all these things together. Thank you, by the way. Thank you for all your help with these. We're bringing all these together into today's last day of the section where there's actually nothing new. It's just kind of making sure we handled all of this. The next time we'll have a review. Next time is Thursday, we'll have a review Thursday. And then I'll see you again on Tuesday of next week. So that's when not a test. I'm still not sure if this is a half test or a double quiz, but we're working that out.
Gonna have to find that day, like, what the papers behind you and after we do that there.
Well, we're gonna have our full day review next time, so probably I think we're just gonna have it. But don't quote me on that. We'll see. It's a new unit. Okay, so let's go to where is this? Like I'm approaching it. Here it is. Okay, so I'll talk you through this one. First of all, we take a look at the expression. We see that it is a rational function with the top and bottom equal. Therefore, it has a horizontal asymptote. Y equals 3/1, which is of course 3. And what does this have to do with the end behavior? Well, all this is saying is that as x approaches infinity, sorry, as I wrote y, as x approaches infinity, y approaches 3. As x approaches negative infinity, y approaches 3. So that's how you write the end behavior for these rational functions. Factor to find any vertical asymptotes. Factor specifically the denominator. Vertical asymptotes come from zeros in the denominator. So x minus 2, x plus 2. And we see that we have vertical asymptotes at x equals plus or minus 2. Is that clear so far? Any questions? Any x-intercepts? Let's do the y-intercept first. That's always easiest. Y-intercept. See what that y-intercept is? I think x equals to 0, so y equals 3 times 0 squared over 0 minus 4. Sorry, 0 squared minus 4, which is equal to 0 over negative 4, which is 0. And since our y-intercept is 0, I think that the x-intercept will also be 0. Any questions? Okay, anything else here? Check where the function is positive and negative. This helps with the behavior of the graph at vertical asymptotes. Okay, check where it's positive or where it's negative. See what they want us to do here. And we have to decide, is this going to look like this? Don't write that down. Or do you see what the other thing it could be in between the asymptotes? This or this. Someone listening? Maybe. Let's plug in a number. Is that you? Who's whistling? Someone's whistling. It's so strange. So what I think I'm going to do is I am going to use my calculator to plug in some points. You're going to have to do this in your homework, so I want you to be able to do this quickly and efficiently. Okay, so Desmos. Well, Desmos. Okay, just watch for now. Let's see.
And it's kind of very well. Pretty good, then. A bag? Or a verse what?
Here we go. Okay, so what I'm gonna do is. Yeah. Yes, nothing hidden here. And I'll go slowly. Okay, we don't have a whole lot of experience with the calculator, so it's important to do this systematically. Okay, to get to the screen, you hit the y equals button. And I want to type in the function, which I think I lost it on my, like you can't see here, but was it on top was 3x squared? Is that right? And since this is rational, do you remember where that fraction function is on the calculator? Alpha, and then the variable. So top is 3, my variable is right here, x squared over x squared minus 4, is that right?
So you can't just do like, you can't just do the divided.
You could do the divide, you could do like divided by, and just make sure it's in parentheses. It's just a nice feature. Oh, of course. A good point. You can't see anything, right? Can you? So to get to this fraction part, it is alpha x. That gives you, that sets it up for a fraction. We just make sure your neighbor's okay with this. Working out okay?
Yeah.
Now, our goal is to graph this by hand, and we're using this as a tool. So I don't want you to look at it. We're just going to use this to plug in some values. Can I answer your questions up until here? Next step. We're going to use a table of values to plug in points. Like instead of like plugging in a 1, a 2, a 5, like we may want to plug in multiple points. You have to do this on the homework. So this is important for that, just to help you out to use the speed. We're going to use a table function, but before that, I want to go to table set. So second, then window to get here. And please make sure independent is ask and dependent is auto. Yeah. So in table set, which is from second window, you want to make sure, and you can copy it from here. Independent, ask, dependent, auto.
That's like, are we gonna talk to what's going on?
I don't know. I haven't seen the test yet. Probably not. Are we okay? So this is table set, which is second window. And then to switch the options, I think you just hit enter. You just go to the option you want and hit enter. F and auto. Can I move on? So now I want to put in these values. So I'm going to go to the table, not the graph. I'm going to go to the table. And anytime it's in blue, so it's you have to hit second. So second table. I have some stuff here, so I'm gonna go ahead and clear that. How do I clear this? So what this allows is we could just type in any number we want. So for our graph, it would be helpful, I think, to plug in like a 1. If I type that in, then the output is a -1. If I want to know what happens for a 5, I just type in a 5. It gives me that number immediately without having to do that work, which I know you could do, but it breaks the tedium of doing the details. Any questions about that? Okay. So I'm going to go back to and I think that 1, -1 actually gave me all the information I need. All the information I need. Here it is. So 1, -1, that means this point right here is on the graph. So do you see which way this branch is gonna go? It goes down this way and up this way. I'm gonna plug in 2 more points. Like, what do you think I'm gonna plug in? Well, we haven't finished it yet. I want to see what's going on over here on this side. You can see there. On the right of the vertical asymptote, it's either up here or down here. Because remember, those asymptotes are guides. So to figure out where it goes, I'll talk about 2 different ways to do it. First way is very concrete. I'm just going to plug in that 3. If it's more than 3, it'll be above. If it's less than 3, it'll be below. And when I say 3, I'm talking about this value of 3. Excuse me. Is it?
5 and 5.5.
5 2/5? What just happened? Hello. Okay, so I'm sorry, when you typed in the 3, what did you get?
I don't know why.
The 5 2/5? Okay, so it's gonna be like up here. This stuff is gonna be up this direction. So you can either do it that way, or you can realize that there's no way it could be below, because if we're below, there would be another X intercept. It can't be below. There's only one X intercept. It can't be done. It kind of has to be okay. By the process of elimination.
Same with the other thing.
Same with the other side.
Just gonna be real quick.
Yeah, on the other side, if we say, well, but it can't be this. It can't be that, because there's no other X intercept. Oh, I think I messed up. I messed up. I failed to recognize this.
Wow.
A multiplicity of 2. So just like with polynomials, when it's multiplicity of 2, it touches. So excuse me. Yeah, that's quite different, isn't it? I'm sorry.
Like what?
So we have a 0 that's multiplicity 2 here. We haven't seen that. Multiplicity of 2. So just like with polynomials, it touches and then turns away. Right? If it would have just been X on top, it would have gone through the way
So
That's
what
right.
you put for this is being find out based on the numerator.
multiplicity is based on the exponent.
So whatever the degree of the numerator is. So say it's like
Let's talk about
3x,
3.
say it's like 3x cubed plus like.
If it would have been like this, let me do this.
But 3.
But like I said, that's the numerator. Like over x squared minus 9 or something.
And what if you're like, what if that's like a, what if the denominator, what if it's bottom heavy with the, we'll have like top up.
Well, let's go one at a time. There can be a bunch of examples that we're gonna go through today. Pardon?
But the.
Oh, this is a whatever, like
Right, the
just in
top
case.
left is it.
Yes, but this will be like this.
Say back.
Yeah, this should be what it looks like.
But
So if you want to take a look at your calculator's graph and see what it looks like.
no.
Hey guys. Hey guys. Is that what it looks like when you hit the graph feature on your calculator?
I don't know.
Something like that?
Looks like what do you? What the hell?
Yeah, okay, so graph the function, done. Go to Zoom standard, so Zoom and then 6. Gentlemen, I've asked you a few times already. So it looks something like that.
Yeah.
Just like that. Oh,
I think mine's like the vertical axis, mine's like down the.
Thank you.
Yeah, let's make it first here.
By going to. Let's go here. Oh, Ben, that's you whistling. Stop it.
Yeah.
You got me.
Just gonna do one last thing. One last thing. Focus, guys. What was for lunch today? Jeez. Jack, you okay? I'm gonna put in the y-intercept, say the horizontal asymptote, so y equals 3, was it? Oh, this is just to visualize, now that we have the graph on here. Because I wasn't trying to graph it here, but now that we finished it and we're checking, I wanna see the horizontal asymptote, just to make sure everything is fitting well. It works out okay? Look at that, and it's approaching those. It looks like it's touching it, but it isn't. It's coming close to it. Yes, Jeff?
Is there a reason that there wouldn't be another shape like, that's like mirrored off of the one on the top? Like, moving up to the, or like.
I'm gonna answer your question to you directly, but I want to first get everyone back to. So if you'll take a moment to try example 2. I'm sorry.
Why wouldn't there be like wouldn't one that's like here? Oh, okay. That's just kind of how they operate. I think I would have another.
Guys are working on time, you know? Putting it together as. Remember, horizontal asymptotes are in dash. What should be that? It's not actually part of your graph. So, we don't start 3 and 1. Wow. I will try, I can help me out with this. Well, here's all one.
Oh.
Oh, for now. For now. What do you got, that one go? Something about it? Okay. You're always ready. So how you like?
I guess that would make sense.
About one more minute before we discuss. Yeah, I think you've had enough time to get some good information. Luke, what'd you find out about this function? So I need an equation. Y equals 2, I think it's like 2 over 1. I don't need that, but I need the Y equals part. Yeah. Okay.
You want me to write that here?
Yes, please. Okay. Are we good with this, everybody?
Yeah.
Nice, thank you. Yeah, horizontal asymptotes are actually really nice to find. If they're equal, it's just a ratio of those leading coefficients. And if it's bottom heavy, then the horizontal asymptote is Y equals 0 if it's bottom heavy. Okay. Thank you. Miro, can you tell us something else about this, please? Then leave her alone. Okay. The X, is that for the asymptotes or is that for an intercept? Okay, I think if you're setting X equal to 0, then you are finding a Y-intercept. Right, that's when X is equal to 0. So you're on the right track, but not for vertical asymptotes. So Y-intercept X is equal to 0, and in that case we have 0, comma, -1. So did I do that right? X equals. You're saying that negative over -1 is 1? Okay, I miscalculated. Thank you. And I think that's what you said also, the 1. Yeah. So 0, 1. So we actually have a point, 0. So we have the Y-intercept. 0, 1. Okay, Miros, was there anything else? James? Upton, please. Oh, what's that? Find the x-intercept, okay. Nice. I we set the whole problem equal to 0. We didn't have to do this last time because yeah, the x, yeah, both of them were 0. In this case, since the y-intercept is 1, x-intercept has to be something else. You okay then? So we set this whole thing equal to 0, and then we get. Did anyone get this? 1/2. So x equals 1/2. So we have 1/2 comma 0. Right there. Okay. Thank you, Rose. Would like to continue. Yeah, Jack.
And the vertical asymptote, basically, you have to, yeah, basically, that really low is really
Yeah, that is the key for vertical asymptotes. It's a denominator. Can never divide by 0. So x minus 1 equals 0. So x equals 1, and that is our vertical asymptote. Is this filling in nicely? Do we see where the rest is going to be actually? Okay, check where. Why does it keep doing this? Okay, so I think we just follow this. Right? These asymptotes are the guide. So we do this. And do you see where the graph is going to be on the other side of that asymptote? There's no other x-intercept, so it has to be top right. There we go. Done. Any questions? I have a question. Why are about 5 of you so squirrely today? Is that what it is? That's serious. That's serious. Jack's not one of the squirrely ones. So control yourselves, please. Yes, sure. Okay, go through example 3. And example 3, one moment, please. And example 5. Just want to kind of discuss your strategy for this. What do you notice about the function? Yeah.
How do I put it in? Pretty tough problem. Yeah. Oh, yeah.
One of the first thing you learn to notice is that you take a look at the degrees and you say, hey, this function is bottom heavy. That's how we know it has a horizontal asymptote at y equals 0. So y equals 0. So as x goes to positive and negative infinity, y goes to 0. I'm going to be lazy and not write that out. You can't do that on a quest. A vertical asymptotes. 2 and negative. Who already has these 3 bits of information on there? Unfortunately, we haven't actually graphed anything. The fact that these are dashed means there's nothing on the paper, but we're at least setting ourselves up for success. X or Y intercepts. Does it have either? The easier one, as always, is a y-intercept. Do you see what the y-intercept is? Be careful. Is it 3 over 2? That's correct. -6 over -4, which is 3 over 2. So y-intercept.
intercept is 0.3 halves, so we have something right here. Is there an x-intercept? 0. There's no need to multiply this out. You can see here that we have an x-intercept of 3. Multiplying it out kind of gets in the way of seeing that. Okay, and now we have to figure out where these branches go. There's only one that's obvious. In between the two vertical asymptotes, there's only one place this could be. And it's not here. Because if it were there, there'd be another 2 more x-intercepts. So it has to be here? No, I've done poorly. I did a bad job. It's kind of like a problem. Okay. Now that x-intercepts on that horizontal asymptote is a little bit strange. So to get a clue as to what this looks like, I know from experience it's either going to be this. Does that make sense? I would have to do that? Because remember, it's a horizontal asymptote is the limit as x goes to infinity. So here we have very small values of x. It could actually cross it, but as x goes to infinity, the function. It's either going to look like that or this. Because remember also, asymptotes are just guides to make your graph. So in order to figure out which one of those is going to be, I'm going to calculator and I'm going to plug in. I know if I plug in 3, I'm going to get 0. But the number's around 3. Maybe not 2 because x can't be 2, but I could plug in maybe 2.5 or 4. 4 would be a good one to plug in. Maybe I'll just do that without my calculator. Or I know. Yeah. Or you can see that plugging 4 in here, I think, is quite easy, isn't it? 2/12. So I see that we have a tiny positive number, which means it's going to do this. On the other side, I have one more branch to draw. Right, Ben?
Yeah.
One more branch. How do I decide where that branch is? Well, I can't mirror it because there's no other x-intercepts. So I'm going to eyeball it partially. I want a good eyeballing. I'm gonna plug in -4 or -3. Anything on the left of that -2. So f of -3 gives us 2 times -6 over 9 minus 4, which I think is a negative number, isn't it? It's negative. I don't even care what it is. I know it's all negative. You can check that on your calculator, or if you have your maybe you can check Desmos, but it should look a lot like that. As far as I know, it's not going to be calculated. We'll see. I may have to give you like these calculators. These images full function. It's definitely not graphics. No, this is a page. Electrical technology. Because I plugged in this -3, and I was saying that I get a negative number. Same thing up here. Yeah, there's no clue here like there was in the last one. We'll see. For now, actually, I'm going to stop going over problems. I'm going to ask you to start on your homework, either the book or the one for the my math lab. Good job today, guys. That was a lot.
Jazira, did you finish? Are you done?